Hello and welcome back with Mrs. Struble. Today we're going to be talking about parallel lines and transversals. First thing we're going to do here is kind of discuss some notes. Background information first. When we have lines that are on the same plane but they do not intersect, that's what we call parallel lines. And they're notated as parallel lines by using a little arrow marker on each line pointing the same direction. When we write that lines are parallel to each other, for instance, these symbols indicate that line P is parallel to line Q. But if I were to write that, I would say P, and then I'd have two bars straight up and down, Q. This says P is parallel to Q. Okay. When we have lines that intersect at right angles, that is what we call perpendicular. That is noted by the right angle symbol. Okay? And when we write them in math form, we could say that L, and then we do kind of an upside down T. This means perpendicular. M. L is perpendicular to M. Okay? When we have a line that cuts or intersects parallel lines, like so, I know it's not exactly straight, but this is what we call a transversal. And that is what this lesson today is about. Okay. When that happens, we have several different pairs of congruent angles that are formed. First, let's talk about corresponding angles. An angle is corresponding when it's at the same location but a different intersection. Okay, so same location, different intersection. Again, in order to have corresponding angles, we do have to have a transversal that is intersecting one or more pairs of parallel lines. And when we find those corresponding angles, in this example, we have this red angle right here is a corresponding angle to this one down below. They are both in the top right location of each intersection that occurs between the transversal and the parallel lines. Corresponding angles are congruent. Right. Some other things that are good to know when we are dealing with a transversal. We form what are called interior angles and exterior angles when you have a transversal. So as noted in this diagram here, the interior angles are those angles within the parallel lines that are formed. Okay, so in this example, 3, 4, 5, and 6, those are all what we classify as interior angles. This is going to be important when we start talking about alternate interior angles and alternate exterior angles. As noted, if they're not inside the parallel lines, they are outside, meaning exterior. So the exterior angles here are angle 1, 2, 7, and 8. When we are talking about an angle relationship that is called alternate angles, what we are meaning is they are on alternate sides of this very important transversal line. Okay. So when we have alternate interior angles, that means we have interior angles inside those parallel lines that are opposite sides of the transversal. So one is on the left-hand side, one is on the right-hand side of that transversal. These are what we call alternate interior angles. The important thing to note about alternate interior angles is they are congruent. As you would assume, alternate exterior angles are perpetually the same. The only difference is instead of being interior angles, they are exterior angles. Okay? So they are on the outside of that parallel line, And they are alternate exterior angles because one is on the left-hand side of that transversal and one is on the right-hand side of that transversal. They are on alternate sides of that transversal, but they are both exterior angles. Important thing about alternate exterior angles is, hopefully you've guessed it, they are also congruent to each other. We've got lots of congruencies going on when we have transversals and parallel lines. So this is a lot to process, many different diagrams to process all of this information. Let's put it all in one. I find it best to do this using a color code. So we're going to go ahead and keep the interior and exterior angles this same color. Okay, so exterior angles, we're going to go ahead and keep them that pink that we were using. And over here, we can make a little key here. We've got exterior angles. Go ahead and note those right there. Okay. These are also down here, exterior angles. All right. And then the insides, well, there's our interior angles. So let's go ahead and label those interior angles. Okay. Now we have a bunch of different other relationships that are being formed. We have corresponding. Now again, if they are corresponding, they're in the same location, just a different intersection. So 2 and 6 are examples of corresponding angles. And corresponding angles are congruent. That's why they're important to know. We have alternate exterior angles. Well, alternate exterior angles, one example would be angle 1 and angle 8. The other pair of alternate exterior angles is angle 2 and angle 7. Okay, so there are multiple pairs of each type of relationship, but it's going to be important to notice them. Alternate exterior angles are once again congruent to each other. Then we have alternate interior angles, and I'm going to go ahead and abbreviate here. Alternate interior angles, such as angle 4 and angle 5. And once again, those are important because they are congruent. Okay. Again, lots and lots of congruencies going on here. There are so many different other relationships that we've already learned about that are occurring. So we have lots of supplementary angle pairs. So 5 and 7 are what we call supplementary angles. We have vertical angles. So 5 and 8 are what we call vertical angles. 6 and 7 are vertical angles. Remember, they're opposite of each other on that intersection. But that, in a nutshell, is the angle relationships that occur when we are given a transversal line that passes through one or more pair of parallel lines. Okay. Let's try this in action, shall we? First step. All right, so let's practice finding angle measures. If I have a diagram right as shown, can we identify the measures of angle 1 and angle 2? And knowing what we know now, we can. So if you take a look, we are given this angle. The measure of that angle right there is 110 degrees. So If we were wanting to find angle 1 first, let's take a look at what kind of relationship we can tell or we can see between angle 1 and our given angle, 110 degrees. You can picture this diagram up and down, or if you want to, you can turn it to the side, and hopefully you'll be able to see after turning it to the side, we have an angle that's in the same location, but a different intersection from each other. This, again, is called corresponding. So angle 1 and 110 degrees are corresponding angles. Because they are corresponding angles, the reasoning is very important here. So because they are corresponding angles, we now know that angle 1 is also equal to 110 degrees. All right, now taking a look at angle 2. What do we know about angle 2 and 110 degrees, or maybe angle 1? We have to find a relationship between angle 2 here now. So again, looking at it horizontally, we can all turn the paper. Okay, angle 2 sits right here. There's several different ways you could do this, but the short gist of it is we already know that angle 1 is 110 degrees. And if we use our prior knowledge, we can see that angle 1 and angle 2 form supplementary angles. Angle 1 and angle 2 are supplementary. If they are supplementary angles, they add up to 180 degrees. Angle 1 is 110, plus angle 2 is going to give us 180 degrees. That's the definition of supplementary angles. And we already substituted our value in for angle 1. So what's left? Well, solve for angle 2. 180 minus 110. Angle 2 is going to be 70 degrees. Let's let you give it a shot. Find the following. Now that you've tried this on your own, let's go ahead and see how you did. For example 1, or try it number 1, angle 1 is 63 degrees. The reason that angle 1 is 63 degrees, and remember you had to explain your reasoning here, very important, okay, is because the given 63 degrees and angle 1 are corresponding angles, and corresponding angles are congruent. Okay, so angle 1 is corresponding to angle 63 degrees. Try it number 2. You had to identify angle 2. Well, we already know that angle 1 is 63 degrees, and using our prior knowledge, we know that angle 1 and angle 2 are supplementary. If they are supplementary, they add up to 180 degrees. 180 minus 63, 117, is 117. So angle 2 is 117 degrees. Here's another example. Here we're going to focus on our newfound vocabulary. We're going to use angle relationships such as corresponding, alternate interior, alternate exterior, and we might even throw in some prior knowledge of vertical and supplementary angles. Our objective here is to use this figure and find the measures of all of the angles that appear. We are only given one. Okay? So if we take a look at our given 75 degrees, some of us might like to start at angle 1, right? Let's just do angle 1 first, because why not do them in order? So what would the measure of angle 1 be? Well, we only know one other angle. So does angle 1 and angle 75 have a relationship? And sure enough, they do. They're vertical angles. And if we recall, vertical angles are congruent. So angle 1 is also 75 degrees. Why? It is vertical to the given angle. Okay, plural. Let's try angle 2. Taking a look at the relationship between angle 2 and what we already know, angle 2 is supplementary to both the given angle and angle 1. Therefore, angle 2 is 105 degrees. The reasoning is it's the supplement of angle 1. Or you could say it's the supplement to the given angle. Either one works. Okay. Now we know angle 2, let's check out angle 3. Again, we could also say, hey, angle 3 is a supplement to angle 1. Or you could go and use the vertical reasoning and say, well, angle 3 has to be 105 degrees because it's vertical to angle 2. And vertical angles are congruent. Okay? You can use either reasoning. So angle 3 is 105. And now we gotta get started on our new vocabulary in order to conduct reasoning here. So if we take a look at angle 4, compared to the angles we already know, let's use our given angle. Okay? So angle 4 compared to our given angle of 75. These are what we call alternate interior angles. Okay? One is on one side of the transversal here and one is on the other. They are both interior angles. So angle 4 is also 75 degrees. Why? Alternate interior angles are congruent, and it's the alternate interior angle to the given angle. Okay? So now we know number 4, angle 4 rather, not number. Okay. Let's do angle 5. Again, we're focusing on our new vocabulary. So when we take a look at angle 5, comparing it to something we have already found in the other opposite section, we could take a look and say, hey, you know what? Angle 5 and angle 2 have a relationship. And that relationship is they are corresponding. Corresponding angles are congruent. So angle 5 has to be 105 degrees. Why? It corresponds to angle 2. Okay. And then we keep going. Hopefully you're noticing a trend here. When you have a transversal with parallel lines, the only values you're ever going to get are 2 different numbers for the measures, which is kind of cool. So it's either one or the other. Angle 6, well, angle 6 and angle 1, what's the relationship there? They're both exterior angles. They're congruent because they're alternate exterior angles. And finally, angle 7. If we take a look at angle 7 and let's compare it to angle 3. What do you notice about angle 3 and angle 7? Hopefully you've seen that angle 7 is 105 degrees because it corresponds to angle 3. All right. Now that we've done it together, why don't you give it a try? Pause the video and then try and find the missing measures. Now that you've paused the video, and tried these, let's go over what you found to see if you were correct. Turns out angle 1, angle 3, angle 4, and angle 6 are all the same value, 121 degrees. Now your reasonings are important, so make sure you're also explaining these as to why they're 121 degrees. And as we saw in our example, your reasoning can vary. Okay? You can use whatever other angle you want, as long as you already know that angle, in order to explain your reasoning, and just kind of go from there using all of your vocabulary you've learned. All the other angles, angle 2, angle 2, angle 7, and angle 5, all of the other angles are 59 degrees. All right, one last thing here. Real life situation, where does this come in handy? Well, it comes in handy, believe it or not, when taking a look at many types of maps or even airline strips. This is an airline layout. You had the opportunity to draw one of these yourself just shortly before we started this unit. And hopefully, with that project, you noticed the same trends that we're talking about here. Okay? So here, we're going to practice one more time. We're going to use this airport layout, and we're going to describe the relationship between each pair of angles that are noted. The first group of angles we're going to look at is angle 3 versus angle 6. So taking a look at those two angles, angle 3 is over here, angle 6 is over here. How are those related to each other? Feel free to use your vocabulary for now, but make sure that you have learned these vocabulary come test time, or even quiz time would be better. Angle 3 and angle 6 are what we call alternate exterior angles. You can abbreviate it as such. Alternate exterior angles are congruent, so once we figure out one, we know the other. What about angle 2 and angle 7? Angle 2 is here, angle 7 is here. Taking a look at those two angles, again, hopefully you've noticed that these are a pair of alternate interior angles that are formed in this diagram from the transversal. All right, your turn. Okay. I've got 3 problems for you. It's the same diagram, but I want you to find the measure of angle 3 if angle 4 is 84 degrees, the measure of angle 5, and the measure of angle 6. So your job is to find angle 3, angle 5, and angle 6. Make sure you support your reasoning as well. Pause the video, find those 3 angles. Now that you've tried, let's go over the answers. Angle 3 and angle 4 are supplementary angles. Therefore, angle 3 is equal to 96 degrees. When looking at angle 5, compare it to angle 4, and you notice that those are alternate interior angles, and alternate interior angles are congruent. So angle 5 is the same as angle 4, 84 degrees. Angle 6 and angle 3 are alternate exterior angles, so they're congruent. However, angle 5 and angle 6 are supplementary angles. So we could use that relationship as well. And we still end up with angle 6 being 96 degrees. In this video, we have learned how to identify angle relationships that are formed when we have parallel lines cut by a transversal. We have also practiced how to find missing angle measures when a transversal and parallel lines intersect. Thank you for watching. Until next time, this is Mrs. Struble with Struble Math. Bye!